Aloha, my name is Kelly Hwang, and I am currently an AS&S Computer Science degree seeking student at Kapiolani Community College. My project from this year's PEEC2 STEM Research Experience Vertical Integration is using LEDs for visible spectrum color therapy along a temporal axis. My project this year was a twofold inspiration. The first fold being Hawaiian mythology regarding rainbows, and then the second being mood rings. So traditionally, Hawaiians believe that the rainbow is a pathway between the physical and the spiritual worlds. And, and then spiritually, the rainbows kind of signified as sad omens and also as a sign of Ali'i being near. Furthermore, rainbows were also used as weather forecasts, such as when the male upside down rainbow would come, the kuhonu, there would be flash floods would be predicted to come straight after that. Of course, the rainbows are created by water droplets refracting light, and it was this quality of rainbows and the story that made me interested in creating my own light source using an LED. Um, and furthermore, and also talking about mood rings, that I was always fascinated about how it was controlled by a temperature variable, and then color would kind of be produced from that. However, I could not do a project similar to a mood ring as the temperature is very temperate here in Hawaii, so there wouldn't be much change. Uh, and then for another sensor, I could have done brightness, but again, but to mimic the sun setting, but I thought it would be too difficult and not reliable because there's much light pollution from where I live, and also there's light pollution from indoors. So then I arrived at my final decision of using time as the variable because time is guaranteed to change. There is no stopping time and it will always be the same every day. And so I wanted to use that quality of time. So my eventual goal for this project would be to optimize my daily schedule by creating this LED that would follow my daily schedule and output different colors at specified times. So throughout this process, there were many new techniques and technical skills that I learned, mainly to do with the Arduino coding, but also a very important skills of how to do basic circuitry and also how to use all these myriads of different sensors that we were given. For the first iteration, using this single LED, the RGB LED, originated from two base codes that were given by the LEGU Arduino files, the one being for the DS1307 RTC real-time clock module, and the other for the RGB LED. So I put those two kind of base codes into one sketch and successfully ran it, and then from then on, I used my code flow chart to finalize how I was going to actually put the coding to not just together in one file, but to work off each other. So deciding between if statements and switch statements so I can choose which colors to come at what time, I decided to eventually go with the if statements just because it was easier and more adaptable for my usage as I would be using a range of values and it was very flexible. I initially began by coding from like the first second to the fifth second and the sixth second to the 10th second and so on, just doing static colors, and it worked quite well. And so I kept on developing that code, and eventually I arrived at uh, deciding to use time minutes as my variable, which time minutes was given by clock dot hour, so the hour times 60 and then plus clock dot minute, as each time of the day would have a unique number. So this is the way that I use the if statements in conjunction with the time minutes and using the different conditionals. So I it eventually became 16.5 hours of RGB LED screening, and there were two types of codes that I used. The first one was a static one, which is on the left of the flowchart, where it's given a single value of red, single value of green, single value of blue, and then the middle longer column is the four loops that I used for the melding of the colors, blending of colors from one to one. For example, orange to green, I would need to gradiate it between the two, and it was trickier to do, but I managed to do this by incrementing the additive primary color with the largest change in between, for example, red. And then I would use the four statements to either increment or decrement the other two colors, the green or blue. Some problems I encountered during this coding process were regarding the conditional statements for time minutes, as before I had, time minutes is less than and more than in one little bracket, and the Arduino code did not like that. So unlike in math, I had to do the less than one and then use the logical and then more than. So that was a little hiccup. And choosing and stacking conditional if and for statements, that was also kind of, with all the curly brackets, it was easy to get muddled up. And then for the last thing I had to do to make it my final iteration was converting the code to using fast LED for the LED panel, and that was also more trickier. So I chose 12 colors in total, which were specifically chosen due to their relevance in both chromotherapy and also in Hawaiian mysticism. Chromotherapy basically details that the colors, each individual color has a specific wavelength and oscillations, and then those two in conjunction would heal both the physical and the etheric bodies. So as you can see here, there are many. This is just the layout of what time I wanted to do each activity, what color I wanted to do each activity, the color RGB values, and then in between for the four statements, as I showed you in my previous slide, there would be the change in R, the change in G, and the change in B. So I would start the morning off with amber, as it was a very good kind of warming and the warming aura, and it's a good color to wake up to. It's also quite bright, so it kind of shines in your face. It's like having the windows open, having the sun natural light wake you up. And so the blue would be an important color to use during the PEEC program, as it is used for deep thinking and meditative states. So because especially darker hues such as lapis and navy blue, which is what I ended up going with for the PEEC2 program, it kind of gave you more concentration and discipline. Red, comparatively, it stimulates the basic self. So the light red would be a very good follow-up after PEEC, and then ruby red, which would elevate the physical energy. That would be good for my daily workout session after that. Turquoise is a universally uplifting and neutralizes negativity. So that was an awesome color to start my wind down at the nighttime with. And then this, after the grounding of the physical level, then there would be grounding for the vibrational level with brown, and then grounding for the spiritual for magenta, and then forest green for the grounding of the mental. And then the final iteration of the project was eventually done by replacing the RGB LED with the WST12B panel. And my particular one was 8x32 pixels. And this was done by converting my code that I previously had before into one that was readable by the Fast LED library. And it also involved an external power adapter. And I also learned that you need to keep the pluses and minuses in the correct location, as I nearly burnt a hole in my desk. There was some difficulties in the transition of coding, of course, as I had to learn kind of basically a whole new language, even though I knew it a little bit, but eventually it successfully turned on, and it is, I'm glad to report, still functioning quite well. These are just the diagram and also the photo of how it was set up. So through this project, a successful project, might I add. I've gained a deeper appreciation and understanding of Hawaiian mysticism, especially to do with color and how to kind of use color. Uh, this is, of course, my project was only to do with light, uh, and I could use Hawaiian mysticism and dress also depending on my mood, and that's also kind of suggested. So definitely that's something I'm going to take forward. And along with the technical skills that I learned to do with electrical engineering and also coding, I now know Arduino colors pretty well. This program also taught me problem solving, and I definitely want to do another research project like this again, perhaps uh, in a different area of engineering, or continue on this project. And my initial goal of optimizing schedule has definitely been achieved, as I'm managing to wake up at around, the time where it starts, like 7:38, without an assistance of alarm clock, which is what I wanted to do, as the alarm clock was just so loud. Uh, I've also managed to kind of look at my phone less and clock less to check all the time on all the time, and just slowly get used to the change of color to do this. These are my references, and I'd also like to acknowledge the many people who made it possible for me to successfully do this project this summer semester of 2020. Thank you to Dr. Aaron Hanai and Jacob Tyler, my advisors, Josh, my PEEC2 coordinator, Leanne, the undergraduate research experiences coordinator, the wonderful peer mentors Alden, Marvin, Jane, Kiana, and Patrick, the Pre-Engineering Education Collaborative 2 grant, and then the National Science Foundation. Thank you.